We've seen how to calculate confidence intervals, which is what fraction of the time are you going to be within a certain number of standard uncertainties of the mean value. Now, a very closely related problem is calculating two-tailed probabilities. This is the probability that you're going to be outside a certain number of standard uncertainties from the mean. So it's basically 1 minus the confidence interval. Let's give an example. Let's say you work in a factory producing lithium-ion batteries for smartphones. Now, the batteries coming off your production line are not going to be exactly the same because of slight manufacturing imperfections, slight changes in the chemical composition of what your suppliers give you to put in the batteries, and so on. So let's say they produce voltages of a mean of 4.5 volts with a standard uncertainty of 0.2. However, you are selling them to a smartphone manufacturer which will only accept batteries producing voltages in the range 4.1 to 4.9 volts. Maybe if it's 4.05 volts outside that range, it'll cause some other component in the smartphone to fail. So what fraction of your batteries will fail testing and be rejected? How do we work this out? Now, here is what we expect the probability distribution function to look like. So it's got a mean of 4.5, that's the mu here in the equation, and a standard uncertainty, which is the sigma in the equation, which is 0.2. So this is what that curve looks like. And what we're after is what fraction are going to be rejected. Now that's the ones off this side or down that side, so less than 4.1 or more than 4.9. So if you write it down mathematically, it's the integral from minus infinity to minus n sigma. So it's the integral from there to there, plus the integral from plus n sigma to plus infinity. So it's integral up here. Now we know that the area in the middle is just the error function of n divided by root 2. So the area out in the wings is just 1 minus the error function of n over root 2. Now we can produce a table of that. I've done that here in Python, import maths and the numerical Python, come up with a list of all the x values, and then calculate the equation, print it out. So what you can see is for n equals 0, what are the odds of being more than nothing away? And of course that's 1. You're always going to be more than nothing away from the mean. The odds of being more than half a standard uncertainty is about 62%. The odds of being more than one standard uncertainty is about 32%, which of course is the reverse of what we were talking about in the last video, which was that the odds of being within one standard uncertainty is about 68%. And similarly for other values. So what have we got in this case? We want the voltage to lie in the range 4.1 to 4.9. Now 4.1 is 0.4 below the mean, which is 4.5 volts. The standard uncertainty was 0.2, so a 0.4 difference is 2 standard uncertainties below. Similarly, 4.9 is 2 standard uncertainties above the mean. So it's n equals 2. We're going to ask what fraction are more than 2 standard uncertainties below plus 2 standard uncertainties above. We want to know the two-tailed probability, because that's both the sides, both the tails of the distribution. So we can get for the table. So 2 standard uncertainties, there's basically a 4.5%, let's call it 5% chance of being outside. I wouldn't be too precise about that. No curve is ever really Gaussian, so saying it's 4.55, it's not 5, is overkill. It's about 5%. So you expect about 5% of the batteries to lie outside 2 sigma, 2 standard uncertainties from the mean, and therefore to fail testing.